I'm Joe Bakhos. I'd like to show a little bit the work I've been doing over the years on this invention. The first time I ever looked at this problem, I had come up with something I called the squeezable plunger bottle, and I filed a provisional patent application for that, and I'd like to show you the drawings for that. I never did pursue it because when I built lots of models, it turned out that when you squeeze the bottle, it made the plunger not be airtight. So here's the liquid in the bottle, and then this green part is the plunger, and the idea would be that when a person used this bottle, they'd squeeze it at the top and the liquid would squirt out. When you let go, the plunger would rise because there's a one-way valve at the bottom and a one-way valve at the top. And so over time, as you use it, the plunger would rise, and then when the liquid was up here, I forgot to color this red, but the liquid would be up here, and then the person would squeeze at the back of the bottle. And as I said, this ended up not working out because I could never get a perfectly airtight seal to stay airtight. When you're squeezing the bottle, the shape of the bottle gets twisted and stuff, and so then it ends up letting air through. So I ended up not pursuing this, but I started looking at patents, all the different types of patents there were out there dealing with this issue. There must be like 20 or so or more, starting from the 1960s all the way to the present. And there were two main ways that people tried to resolve these issues. The first way was they tried to put all of the liquid in the bag. So the liquid's in red here, and these little slashes represent one-way valves. One one-way valve to let liquid out, and one one-way valve to let air in. Now the problem with all of the designs that had liquid in the top was that you could not control how the bag would collapse. And it might collapse in a twisted kind of way where gobs of liquid would be caught far from the outlet, and as the bag crumpled up, you would have a lot of waste. And so this is the problem with this type of design. The other types of patents I saw approached the problem in this way. Instead of putting the liquid in a bag, they had an air bag that as you squeeze the bottle and used it up, the air bag would fill up and displace the liquid. Now the problem with this type of design, it's similar type of problem, is that as the airbag expands, it doesn't expand in a controlled way, and so various parts of liquid would be trapped far away from the outlet. And so that was a problem with this type of design. My design is this, where you have both an airbag and also a liquid bag. And so the collapse of the top liquid bag is controlled because the airbag is expanding, and so it forces the top bag to collapse in a controlled way. And so it solves all of the issues. Keeps the liquid always to the top of the bottle. The liquid area stays airtight for the life of the liquid. And so this just resolves all the issues. My models work perfectly now. The nearest thing on the market that exists is the Crest Neat Squeeze. And they refined the liquid bag version the best way that it could be done. It's still not perfect, but this is the way theirs works. They put a aluminum foil bag on the inside, and there's a one-way valve at the bottom, and there's a one-way valve at the top. And what they did was, in order to try to control the collapse of the bag a little bit, is they glued the sides, or I don't know if it's glue or if they heat sealed it. They heat sealed or glued the aluminum foil bag to the sides of their bottle, so that as it collapses in kind of a controlled way, and they end up with something like this. But as you can see, there's still going to be some liquid wasted and trapped that never gets expelled. And so the way that they dealt with these issues is they made their bottle very small, so it's not designed to be used for a large bottle. And they made the bag out of aluminum foil, which I'm not sure if that controls the collapse or if that's easier to seal to the sides of the bottle. I'm not sure. And they also made their bottle opaque, so a consumer would never be able to see any waste. And and also the aesthetics of it would not look very good if this was a clear bottle. My bottle can be perfectly clear, and my bottle can be large because of the design. You can have a large quantity of liquid. Now, I filed my original squeezable plunger bottle, this thing. I filed this in May of 2007, so I've been working on this whole thing for about 4 years. And I didn't think to save all of the models I made, but I do have some of them here. I'd like to show you them. I just dug out some from in our cellar that I just happened to keep. This probably represents about maybe 1/10 of all of them I've ever built. But you can see all of the different things that I tried, different bottle sizes, different caps that I made. Various ideas that I had. I've been working on this for years and years, and so the models that I have now, they work perfectly, and they're the result of a 4-year process of refining my designs. So I just wanted to share some of that with everyone. Thank you.